All right, welcome, folks. I'm going to be talking very briefly about my position on how cloud FPGA architectures and cloud FPGA programming methodologies need to change to embrace the deployment of FPGAs in the cloud. So, number one, the question that was framed for this panel was that do we really need to think about user sharing? I I'm not 100% sure we need to think about fine-grained user sharing. We don't really need to go and partition up the FPGA into lots of small islands and having multiple users swap in and swap out. I don't think that sort of granularity is expected. But if we look at the architectural changes that are necessary to make this happen, I think there is a win for other design objectives that we might have, right? So you might as well go and make this happen for those objectives in particular, right? So number one, we've seen this already with the Xilinx Versal devices and other FPGA families that a lot of the interface support controllers are starting to get hardened, right? So what this means is you no longer need to spend LUTs and flip-flops and struggle with timing closure for these very essential and commonly used components. So that's a win, even if you don't want to use FPGAs in the cloud, right? Now, within sort of these recent trends, I think the emergence of hardened NOCs is a win that not only makes user sharing potentially possible if you want to break things up and hook them up with NOC endpoints, but it also makes it possible to sort of finally realize the promise of partial reconfiguration, relocation, and making it possible to manage resources rather than think about the entire FPGA, think about smaller chunks of the FPGA in sort of one sitting, right? So it makes design a little bit more modular. And here's sort of a shameless plug for work done by my group, where we look at how the Hoplite NOC can help create these PR regions within the Xilinx PR workflow that's available today. Another thing that has been on at least my wish list and the wish list of a few other folks is the need for sort of a symmetric FPGA architecture, right? So it makes partial reconfiguration easier. It makes modular design easier because when you place and router design in sort of one region of the FPGA, you can literally copy paste it to another region, right? Here's an example of a device that almost gives that to us, the Iconic Speedster, but it's time that the bigger FPGA vendors sort of join the party, right, and make symmetry an objective in the architecture games. And then finally, I want to end, at least for this question, on sort of what open problems do I still foresee within the architecture space for what FPGA should do. We need to look at how to capture state and unload and reload FPGA bit streams easily. It can be done. It's a bit kludgy, so we need maybe some architecture support to make this happen. And then as we start creating these heterogeneous mixtures of RAM blocks and DSP blocks and NOC components, we might need to start thinking about what balance makes sense for cloud applications, right? Let's look at programming models for FPGAs, right? Again, hopping on that NOC theme, I think it's a great advantage even um, within sort of the programming methodology domain. Having NOCs makes it so that you can develop code for possibly sort of a subsection of the FPGA and have that scale to the entire FPGA rather than tackling the entire FPGA in one go, right? So you want to make that abstraction level higher. You want to provide NOC awareness within high level synthesis, right? So again, shameless plug, my group has done some work along these lines with a paper called Leg Up NOC, where we embed a NOC instead of a crossbar between the different sort of partition memory blocks and the FPGA data paths. We need to go further. We need to sort of do scheduling in an NOC aware manner. And then another shameless plug would be to try and look at coarse grain overlays, right? So HLS is great. We want to maybe go one step further and have these coarse grain overlays, which allow you to target this intermediate layer, right? You're programming a collection of ALUs with NOC routing blocks. So it makes it faster to compile. It makes it a little bit easier to sort of deploy applications with the CGRA overlay idea than sort of going all the way to LUTs and registers. Okay, and then again, let me end with a few open problems that I think still need to be addressed. Within the HLS domain, I still don't have a handle on how do we do scheduling in presence of NOCs, right? So some NOCs have deterministic routing algorithms, some have non-deterministic, and then maybe the scheduling algorithms need to evolve to make this happen. How do we match the CGI overlay to cloud FPGA requirements? This is sort of an architecture question, but also addresses the requirements, the software requirements of the cloud applications. And then finally, the PR workflow that we have been trying to improve over the past 2 to 3 decades. We might want to look at how to make improve that further and make it an HLS aware target.